Thank you so much for joining me today. Now, I think this is a picture that, frankly, we all know quite well, the Prairie region. Though this landscape may not have inspired the same kind of rock ballads that oceans and mountains do, they did help inspire the Tragically Hip. And frankly, that's good enough for me. Unfortunately, the Hip failed to capture one important thing in their 1992 classic. They forgot to talk about wetlands. But luckily, I'm here to talk about how this great landscape makes the nutrient composition each one of our prairie wetlands unique. Now specifically, I'm going to be exploring how the differences in pond water properties and land use impact the accumulation of phosphorus in our water bodies. Now you're probably thinking, but why phosphorus? Well, the water that we use every day is really sensitive to changing nutrient composition. And the accumulation of these nutrients really comes from our landscape. But luckily, we have a really awesome buffer. You guessed it, wetlands. Wetlands can capture kind of excess nutrients before they accumulate in our loved water bodies and damage, this resource we value so much. So we've started to investigate what the current concentrations of phosphorus are in our wetlands across the prairies, because, well, we don't totally know yet. So this work uses data collected from 150 wetlands across the prairies. So each one of those dots represents a transect, and on each of the transects we sampled 3 wetlands. Now we sampled pond water in these wetlands, we looked at sediment properties and soil properties to see how much clay, how much carbon was found in these sediments, how saline is our water. But we also looked at, how big are our wetlands and what's growing beside them, and, where are they located in the prairies, because they don't all look the same. But most importantly, we did look at phosphorus. We collected kind of this baseline phosphorus concentration from 150 wetlands. We looked at phosphorus in the water, phosphorus in the soil, phosphorus in the sediment, and we have some pretty cool results. So I'm going to start by talking about those results just at the wetland scale, and then we're going to move to kind of how does the landscape impact our wetlands. So at the wetland scale, we found that pond water alkalinity was actually the best predictor for phosphorus in our wetlands, meaning that as alkalinity increased, so did the concentration of phosphorus. And at the landscape scale, we found some really exciting stuff. We found that wetlands that had crops adjacent to them actually had 2 times more phosphorus than wetlands that were located beside pasture or grassland. So we took that actually just one step further, and we decided to look at kind of all of the different crop types. So we looked at pulses and, a simple rotation, canola, wheat, pasture, and we found some really exciting stuff there as well. So we found that wetlands that were actually adjacent to pulse crops had the greatest concentration of phosphorus than, compared to all other kinds of land use. But you're probably thinking, but so what? Like, how does this help me make a decision, and how can I use this information? Well, I think, the big takeaway from this is that we have so many different wetlands on our landscape, and they can have so many different kinds of functions. So, depending on what's growing adjacent to that wetland is really important, but also where that wetland is located. So I think, recognizing that each one of these wetlands have a unique role to play in our landscape, and all of these facets need to be considered, is a real takeaway. How do we make decisions in terms of land management that take into consideration how phosphorus accumulates in our wetlands? And that means taking into consideration the unique functions of each one of them. So thank you so much for listening today. I've thrown up my email there, so if anybody wants to connect with me, you're more than welcome. And I hope you enjoy the rest of the presentations. Thanks.